Hello dear students of +1 medical and non-medical respected teachers. So today I am going to discuss kinetic energy of rotation and radius of gyration. So it is again a part of chapter rotational motion. So to find expression for kinetic energy of rotation of a rigid body, suppose we have a rigid body, let m1, m2 and so on, mn be the masses constituting the body. Xy be the axis of rotation. Let R1, R2, R3 and so on, Rn be the perpendicular distances of the masses M1, M2 and so on, Mn respectively from the axis of rotation. Let V1, V2, V3 and Vn be the speeds of the particles M1, M2, M3 and so on, Mn respectively. Then kinetic energy of mass M1 about the axis of rotation is given by kinetic energy of m1, that is E1, half m1 v1 square by definition of kinetic energy. Now, but V is equal to R omega, so therefore V1 will be equal to R1 omega. So substituting V1 is equal to R1 omega, so we have E1 is equal to half m1 R1 omega whole square, or E1 comes out to be half m1 R1 square omega square. So this gives rotational kinetic energy of particle of mass m1. Similarly, kinetic energy of mass m2 half m2 r2 square omega square and so on. Kinetic energy of rotation of particle of mass mn will be En is equal to half mn rn omega square, rn square omega square. The total kinetic energy of rotation of the whole rigid body is given by E is equal to E1 plus E2 plus so on plus En, or E is equal to, now half can be taken common, m1 r1 square plus m2 r2 square plus so on plus mn rn square, omega square is also common, or E is equal to half I omega square, where I is equal to summation mr square is equal to moment of inertia of the rigid body. Just like inertia of the body in translative motion, in rotatory motion we take I as the moment of inertia, which depends upon mass also. So I is equal to summation mr square is the moment of inertia of the rigid body. So if omega is equal to 1 unit, E will be equal to I by 2, or I is equal to 2 into E. This shows that moment of inertia of the rigid body is equal to twice its kinetic energy of rotation when angular velocity is unity. Or you can say kinetic energy of rotation of the rigid body is equal to half its moment of inertia about the axis of rotation when it is rotating with unit angular velocity. So this gives another definition for moment of inertia. Then we define radius of gyration. Radius of gyration, capital K, it is defined as the perpendicular distance of the center of mass of the rigid body from the axis of rotation, where whole mass is supposed to be concentrated. Let capital M is equal to total mass of rigid body, which is supposed to be concentrated at the center of mass. So perpendicular distance of the center of mass from the axis of rotation is called radius of gyration. So by definition of moment of inertia is equal to mass into distance square. So it will be I is equal to mk square from summation mr square. So in this case, m is the total mass of the rigid body, k is the perpendicular distance from the axis of rotation. So mi will be equal to mk square. Say this is equation number 1. Say also I is equal to m1 r1 square plus m2 r2 square plus so on mn rn square, summation mr square. So suppose m1 is equal to m2 is equal to so on, mn is equal to m, say all the particles are of equal mass, then m can be taken common from this equation. So it will be r1 square plus r2 square plus so on plus rn square. Now multiply by n and divide by n. N is the number of particles. So then m into n will be total mass of the rigid body. So I is equal to capital M r1 square plus r2 square plus so on rn square upon n. So this is equation number 2. So we have got two expressions for moment of inertia. One is I is equal to m k square by definition of moment of inertia. Another is I is equal to m r1 square plus r2 square plus so on plus rn square per n in terms of normal distances of the individual particles. If you are comparing 1 and 2, so we get k is equal to, this k square is equal to this whole expression, or k is equal to under root square root r1 square plus r2 square plus so on plus rn square upon n. It means radius of gyration is defined as the square root of the mean of the squares of the perpendicular distances of the individual particles. So radius of the gyration is defined as the square root of the mean of the squares of the perpendicular distances of the individual particles from the axis of rotation. It means k has units of length, that is meter. So it is nothing but distance. So this is kinetic energy of rotation and radius of gyration. So stay tuned till next video. Be happy. All the best. Good luck.